the focus of this lesson is going to be, where is the vertex of the angle? Okay, where is the vertex of the angle? So first of all, if the intersection is at the center of the circle. Now, when I'm saying intersection, that means it could be two chords, it could be two secants. If it forms an intersection at the center of the circle, that means that they're central angles. Right? So that would be the situation. There's the vertex of the angle. If this was 55 degrees, what's the measure of angle of arc AC? If this was 55, what's the measure of arc AC? 55. That's a central angle. The measure of the angle is equal to the measure of the arc. That's actually how we define the arc measure. The central angle measure determines the arc measure. Okay, second one, where is the intersection of the two things? So it could be two chords, it could be two secants, it could be a secant and a tangent, but whatever they are, where is the intersection of the two things? Or in other words, where is the vertex of the circle? So if the vertex is on the circle, that means that, what kind of angle is this? Inscribed. So if I told you that this was a 70-degree angle, what does that make this arc measure? 140. Measure of angle APB is 1/2 the measure of arc AB. Okay, now this one was not an inscribed angle, but it acts just like an inscribed angle. Remember that technically an inscribed would not be using a tangent, it would be using two chords or two secants. Since this one is using a tangent and a secant, it's not technically an inscribed angle, but the important thing is the vertex is actually on the circle, so it acts the same as an inscribed angle does. Okay, so if I wanted to know the measure of angle ABD, that's that angle right there. Let's say I told you that this arc measure is, I don't know, 280 degrees. How would you find the measure of that angle? How would you find the measure of that angle, Madeline? That would be this arc measure, and then divide that by 2 would make that 40. Okay, so again, it's not an inscribed angle, but it acts like an inscribed angle acts. Okay, it's still half of the arc measure. So the arc would be 80 degrees, the angle would be 40 degrees. The measure of angle ABD is 1/2 the measure of arc AB. So those two, doing the half or doubling, that's when the vertex is actually on the circle. Now, sometimes you'll have things intersect inside the circle, but you don't really need to do this. I mean, central angles also have a vertex inside, but it's more specific. If they intersect inside the circle, it's not really necessary to use this when they're central angles. If you were looking at this picture and I told you that this arc measure right here is, I don't know, 70 degrees. Is angle 1 70 degrees? No. Why is angle 1 not going to be 70? It's not a central angle. If it were a central angle like this, then that angle measure would be the same. I kind of missed the center a little bit there, which you get the idea. That is 70 degrees. But because the vertex is not at the center of the circle, okay, our vertex is right there. It's inside the circle, but it's not at the center. We're going to have to use that arc and also the arc over here. So we're looking for angle 1. Okay, we're also going to use its vertical angle, and we have to average those two arcs. Okay, so in order to find angle 1, if that was 70 and this was 30, what would that make angle 1? 50. You have to average the two arcs, okay? So the measure of angle 1, this angle right here, is going to be add the two arcs and divide by 2. Now, the arcs you're using are the ones that are cut off, that are intercepted by the arc itself and the vertical angles arc. Okay, so we're using the arc intercepted by the angle you're looking for, and then the one that's intercepted by the vertical angle. Add the arcs and divide by 2. Okay, this is just the average of the arcs. Okay, so we've got 3 different situations right here. We've got central angle, arc and angle are the same. We've got the intersection on the circle, the vertex on the circle. You'll be doing half of the arc to get the angle, or doubling the angle to get the arc. And then we've got ones where the two things, whether two secants or two chords, whatever they are, if they're intersecting inside but not at the center, you have to average the two arcs to get the angle measure. Now, let's go back to the central angle for a second. Does that theorem work? Does it work if I go ahead and stretch these out? What would this arc over here have to be? 55, because why? Yeah, so this would be 55, and therefore that's 55. Is it true that when you add those two and divide by 2 that you get the central angle measure? What's 55 plus 55? 110. Divide by 2, you got 55. So you can use that process for the central angles. It's just not necessary, right? It's a lot faster to just go 55. So it's not that this process doesn't work for central. It's just that the arc and the angle are only congruent if it's a central angle. So don't be trying to oversimplify the ones where it's not a central angle. Okay. Here's your pictures. Okay, angle 1. Brooke, tell me how to do that. Okay, so the vertex of the angle is inside the circle, but not at the center. So we're going to average the two intercepted arcs. 40 plus 52, cut it in half. That's 92, which gives you 46. Okay, for number 4, I'm going to go down. Where is the vertex of the angle? Allison, where's the vertex of the angle? Okay, is that inside the circle, at the center of the circle, or on the circle? Where is that point? Is it on the circle? Is it at the center, or is it inside the circle? It's on the circle. That means that this one is not technically inscribed, but it acts like an inscribed angle, right? So you're using this arc and doing what? We're trying to find this arc here. What do you do with the 74? Zach, what do you do with 74? Okay. So 74 times 2 is going to be what? 148. Is that a major or a minor arc? Minor because why, Sam? Yeah. Remember that arcs that are less than 180 are minor arcs. So even though it's over 90, it's less than 180. All right, where's the vertex of that circle? Frankie, where's the vertex? Inside. So then what will you do? We're looking for this arc. Oh, Frankie, I'm so sad right now. You know why it's not 45? Somebody tell Frankie why it's not 45. Yeah, center. So this would be a 45-degree angle. But that's going to be a little smaller, right? Because it's not at the center of the circle. So when the vertex is inside the circle, you do what? Okay. Yeah, so it'll be average the arcs. X plus 28 divided by 2 should give you your angle measure. Arc plus arc over 2 equals angle. Okay, if you need to think of it that way, there's arc plus arc over 2 equals the angle. So if you are looking for one of the arcs, you still just make a little equation and then solve it. I don't know why I put degrees there. I don't usually. All right, x plus 28 equals 90. What does that give you for x, Frankie? 52? 62? Final answer? Okay, good. All right, number 5. Where's the vertex of the angle? Inside, on, or at the center of the circle? Riley, where's the vertex of the angle? Okay. Now, they're wanting you, see how they gave you the 90 and they gave you the 130? They're wanting you to find angle 5, which is not actually the one that's kind of corresponding to those arcs, right? Thoughts about what to do? Scott? And then what? Do they have those right? Oh. Okay. So you want me to do, that's 220, and then do 360 minus 220, and then divide that by 2? Okay. Why in the world does that work? Uh-huh. Okay. So he's basically saying, and this is one option, there's another way to do it too, but this is one option. When you do 360 minus those other 2 arcs, you're finding the sum of these arcs. The sum of those arcs divided by 2 is supposed to give us angle 5, right? The sum of those arcs is the leftover. If that's 220, those 2 arcs together are 140. So you've already done, like whatever this is and whatever that is. When you add them together and divide by 2, you already know that that's 140. So the 2 arcs added together and divided by 2 would give you the angle measure of 70. Okay, that works. Some people are not going to be happy with that. So what's another way to do that? Scott is correct, but sometimes that's not a favorite method. Another way, Bronson? Okay. Allison? Never mind. Okay. John? Why does it make sense to do 180 minus 110? No, but you're right. It's not a diameter, but you're right. When you average those 2 arcs, you found this angle measure here, right? Why does it make sense? This is 110 degrees right there. Why does it make sense that that one has to be 70? Even though that's not a diameter. Yeah, it's still a line, right? They're a linear pair, so you can just figure out that that one has to be 70. But just be careful. They may not give you the correct arcs. You may not have, because none of those are semicircles. So, you might not have enough to be able to figure out each individual arc here. The way that Scott did it, he was able to figure out those 2 added together. But you don't have to actually even need to know the individual arcs. You just need to know their sum. Okay, so whichever way you prefer, that would make that 70 degrees. My preference is this way, but it absolutely doesn't matter. Whichever one makes sense to you. I think of it that way better. Okay, where's the vertex of the angle? Miranda, where's the vertex? on the circle. Okay, so how do you use the 220? Okay, so this angle is how much? If I wanted to know the measure of, if I stretch out that tangent, trying to make it look straight. If I wanted to know the measure of this angle, I want two different ways to do that. How can I find this angle measure? All the way down, sorry. Here, here. How can you find that angle measure? Two different ways to do it. Riley, what's one way? Okay. One option is just 180 minus 110. Emma, do you have a different way? Okay. Yeah, so what is that arc measure? 220 from 360, 140, cut it in half, 70 degrees. So, you know, when you're looking at these problems, a lot of times there's more than, oops, sorry, I wrote the wrong thing. That was 140. There's a lot of times more than one way to do the problem. Whichever way you do it, you should get the same answer. So kind of notice that you've got a linear pair here, and you've also got a 360 around that way. So both of those, you know, should work out. It should make sense both ways. All right, number 6. Where's the vertex of the angle? On the circle. Okay, so vertex is on the circle. Which arc measure are you using? 160 or this one? Did we use 160 to get the angle measure? Okay, so this one's going to be 200 because 360 minus 160 is 200. So what's the angle measure? It'd be 100. Sorry, my 160 doesn't look like 160. Okay, so this is the angles we already talked about, right? We already talked about central angles. We already talked about inscribed angles, and then those ones that act like inscribed even though they're not. So what's new was you've got two things intersecting inside of the circle where the vertex is not, the point of intersection is not at the center. And then the last possibility is maybe the intersection is actually outside of the circle. So when the intersection is outside of the circle, here, there's 3 different ways it might look. It absolutely does not matter if they're two secants, if they're a tangent and a secant, or if they're two tangents. Okay, but they look different. What's important is where's the vertex? The vertex is outside. There are 2 arcs that are intercepted by that angle. Okay, there's this one and there's that one. Where's the vertex of this angle? It's outside. Where are the 2 arcs? Well, here's the point of tangency. So here's one, and then here's the other one. Those 2 are going to touch, which is kind of weird. It looks kind of weird compared to the other ones, but there's still 2 arcs there. All right, and then this one has 2 tangents. Where's the vertex? It's outside the circle. Where are the 2 arcs? Well, the points of tangency are at M and N. So here's one arc. And then here's your other arc. What do you know about those 2 arcs?
They equal to 360.
They add to 360, right. Okay, so all of these are going to be treated the same, even though the pictures look different. What's important is where's the point of intersection. So the vertex of the angle is outside the circle. They all get treated the same way. The way you're going to treat them is, hi, how are you? I'm teaching.
Yeah,
You're supposed to sit right there.
I just want to say hi.
He just missed being in geometry. So all of these are the same because the vertex is outside the circle. Right now, notice that here's your formula. How will you know if you're going to do arc BE minus arc AD or vice versa? How do you know which way to subtract it? Meg? Yeah, it's going to have to make sense, right? It's got to be a positive value. So big arc minus small arc divided by 2. Okay, so all of these, because the vertex is outside, would be subtracting. Okay, number 1. Solly, tell me what to do. Uh-oh. Everybody be quiet. Solly's thinking. That was a joke. Where's the vertex?
All right, so the vertex is at R.
Okay.
So it's all the way back there. So those lines are inside the circle. They would be what they would just be like d. So we'd have to do n equals angle 1, 1/2.
It looks just like this one, right?
SB and TP.
Okay, give me the numbers.
So you 80 minus 40 divided by 2, so that so R would equal 20.
Okay, and again, the reason we know to subtract is because the vertex is outside of the circle. And again, it wouldn't make sense to do 40 minus 80 because then you're gonna have a negative angle measure. So make sure your answer makes sense. Okay, measure angle 3. So these things are both what? Are those secants, tangents, or chords? They're tangents. So again, it doesn't matter what the things are. What matters is where's the vertex? The vertex is outside, right? So what else do you have to know? So you got your points of tangency here. This is 220. What else do you have to know to find the angle measure? Right. Okay, so the other arc is going to be how much? All right, so that guy is 360 minus 220. So it's 140. Okay, and then what will you do to find angle 3? Sam, tell me what to do.
You subtract 140 from 220 and divide by 2.
Okay. 220 minus 140 divided by 2. What is that, 80, I think? About 80.
Yeah.
Okay, 40 degrees. Now notice that here you had to realize that that makes a full circle. When there's two tangents, they're going to both arcs will add up to 360. Okay, arc LN. This is our unknown, right? We've got two tangents again, but we don't know this arc measure. So when you don't know what something is, what do? We don't know what it is. What do we put there? X. Okay, so let's call that X. In order to find the measure of that arc, what do we have to know? Meg. You're actually doing something different, but this does work. Okay, how do you know that this one is 130? Okay, how do you know that those are supplementary?
Because LM and NM are tangents. We create right angles.
Yes. Okay, that is something we talked about before. That's not what I was expecting you to say, but that works. So if you want to kind of think outside the box a little bit here, since we're looking for this angle, this arc measure, if we knew that angle measure is a central angle, it'll be the same, right? So in that quadrilateral, we talked about how tangents are perpendicular. So that forces the quad adds up to 360. forces those angles to be supplementary. And then that means that this is also going to be 130 because the central angle is equal to that arc measure. Okay, love that. That was perfect. But I'm going to guess that some of you didn't really think to draw those in. So another option, Bronson?
So my last thing was kind of same thing once you've drawn the lines in, but I didn't figure it out via the tangent, I figured it out via the kite.
Okay. It's a kite, so then what? You still have to use the right angles, don't you?
Yeah.
Yeah. Okay, well, you kind of use the fact that it's tangent to get the right angles. Yes. So this thing is a kite, yeah. These are going to be congruent because they're tangent segments from the same exterior point. And that was a theorem we talked about with circles. Why are these congruent? They're radii. So that thing is a kite. That quadrilateral always will be a kite. Okay. So if you think about kind of drawing in the diagonals here, maybe that's what it would look like. But yes, that is a kite. What if you, so here's the points of tangency, and this is what we're trying to find. Can you tell me what this arc measure would be? I want an expression.
360 minus x.
360 minus x. Thank you, Daniel. So if you wanted to do the algebra, and this would be if you really didn't see, because that works really well. If you really didn't see what to do, then you would do the theorem with 360 minus x and x. So can somebody tell me what the equation would be? I'm looking for the angle measure. So I need to subtract the arcs and divide by 2. What's it going to look like? Correct? Equals equals 50, equals the angle, right? Okay, so 360 minus x just means she's using 360 minus x as the first arc, right? And then she's subtracting off the second arc. So 360 minus x minus x. Okay, so if we simplify that, that would give us 360 minus 2x. Okay, what would you do next? Scott, what do you think? Well, that works. Clearly that doesn't work, but there's another way you could have gone. Peter, is that what you're going to say? Yeah, there's another way you could have solved that though. Brooke, what's the other way? Yeah, multiply to 2 on both sides. I thought that was funny. You're like, well, clearly you would do this. That does work, but there are really 2 ways to go. It works well to divide it because those are even numbers, right? And then you've got x being 130. Now, obviously, that's more work than drawing that quadrilateral, but that algebra works out if that's like the way you see it. But I'd also like to kind of find a little shortcut here. I want you to notice that in the picture above, measure of angle 3 was 40 degrees. The measure of the arc was 140 degrees. In this picture, the angle is 50. The arc is 130. What can you tell me about those arc measures and angle measures? Madeline? They're supplementary. Now, why does that work? That works because of what Meg said here, right? That works because the arc is the same as the central angle measure. Oops. The arc measure is the same as the central angle measure. And because these are going to both be 90, that forces these to be supplementary. So even though that's not stated as a theorem, you can use that. This only works if you have 2 tangents. They must be tangents. Okay, so if you've got two tangents, I don't really like my tangent very well. Doesn't look very tangent-y. Okay, if you have two tangents to a circle, the arc there and the angle here will be supplementary. This arc measure and this angle measure will be supplementary. Only if they're both tangents. It doesn't work if you're trying to use that on like you can look up here and see, like if you try to use that, this one is supplementary to that one, that's not going to work. Okay, but if you have two tangents, like the ice cream cone looking thing, the arc here and the angle there will be supplementary. Two tangents, the arc and the angle will be supplementary. Okay, so that is something that you can use, even though I'm not really stating it like a theorem. I mean, we kind of prove it by using Meg's little method there, but that's only if they're both tangents. Okay, where is the vertex of the angle in number 2? On the circle, outside the circle, inside the circle, at the center of the circle. Where's the vertex? Outside. This is the question you have to ask yourself every time you do these problems, because that's how you'll know whether you're supposed to add and divide by 2 on these problems where the vertex was inside versus subtracting and dividing by 2. Marin, tell me how you'd find angle 2. Why do you want me to add them? Why do you want me to subtract them? Yes, the vertex is outside, which means subtract. So 160 minus 80 divided by 2 is going to be 80 over 2, 40 degrees. And again, notice that these are not supplementary because those are not two tangents. You do have one tangent, you don't have two tangents. Okay, arc JP. We don't know what arc JP is, so I'm just going to call that X. Sometimes those numbers are nice, simple, where you can kind of guess and check, kind of figure it out in your head. Sometimes they're not. So I just want to make sure you know kind of how to make an equation there. So again, I know you can guess and check, but if those aren't nice, simple numbers, there's expressions there, whatever, what's the equation going to be? So again, the vertex is outside the circle. Sam?
70 minus x divided by 2 equals 10.
Good. Subtract the arcs, divide by 2, that'll equal the angle. Yeah. 70 minus x. So on this one, you know, back to when I was talking to Scott, instead of dividing by 2 on that one, we'd probably go ahead and multiply both sides by 2 so that we can clear out the fraction there. So x would have to be 30. Now, again, I know you can guess and check that on this particular problem, but they won't always necessarily be such nice numbers like that. Okay. Solly, number 6. Vertex is outside the circle. What do you do?
XY minus NP, but it's catch because you don't know what NP is. So you do 360 minus 290, or you get NP, and that would be 70. So you get 100 minus 70, that would be 30. Divided by 2, that would be 15.
Okay, so Solly said he added all these up and got 290. You might also notice that's 180, right? So that's a semicircle. This would technically be a diameter right there. That doesn't always happen, but it just kind of jumped out to me. That's 180, so this has to be 180. So 70 degrees. Okay, and then he said we're going to subtract 100 minus 70, then divide by 2. 30 over 2. 15. Okay, so again, the crux of everything here is where is the vertex? If it's outside, you subtract and divide by 2. If it's inside the circle, we're going to add and divide by 2. If it's on the circle, we just divide by 2. And if it's the center, you don't do anything. Okay. On the homework, they're going to be mixed together.